Good morning, guys. I'm going to go through this slideshow on layers of the earth. That will be kind of ending that today with a summarizing sheet and moving through plate tectonics tomorrow. So I'm going to read through each slide with you, but then I also expect you to read through the slides on your own to answer the question sheet that has been added to Google Classroom for you. All right, here's a little clip on Journey to the Center of the Earth to get you started. You can watch that when you read through it. It's pretty cool. All right, so our essential question is, how are the layers of the Earth different from one another? This goes along with our standard compare and contrast the Earth's crust, mantle, and core, including temperature, density, and composition. Well, what do you need to know? Well, you need to know the different layers of the Earth, and you need to know their temperature, their density, and composition. Embedded in that slide is all this information. The Earth is made up of three main layers: crust, mantle, and core. As you can see, the crust is less than 1% of the Earth's mass. It's 5 to 100 kilometers thick. We have not been able to drill past the crust, so they actually get their information from the mantle and the core that we know of based on seismograph information. Waves that are sent through the Earth and that travel back. Mantle is 67% of Earth's mass, 2,900 kilometers thick. The core is 33% of Earth's mass, 6,856 kilometers in diameter. Think of the layers of the Earth like the layers of a cake. You have the crust, which is the icing, the mantle, which is a red velvet cake, and then you have more icing. The outer core is the yellow cake, and then the inner core is the white cake. Okay, first we're going to talk about the crust. There are two types. There's the crust located underneath the ocean and the crust located on the land. You have the oceanic crust and the continental crust. The oceanic crust is the thinnest layer of the Earth that ranges from only 2 miles in some area of the ocean floor to 75 miles deep under the mountains. It's made up of large amounts of silicon and aluminum. Two types of crust, the oceanic crust and the continental crust. It's composed of plates on which the continents move. And that's what we're going to move to next, are those plates. We're going to be talking about plate tectonics starting tomorrow. The Earth's crust is like the skin of an apple. Turn to an elbow partner and discuss why this statement is true. If you don't have an elbow partner close by, call your parents in or talk to your dog. Tell them, why is the crust of an apple like why is the skin of an apple like the crust of the Earth? And then try to come up with another example. Try to compare it to a hard-boiled egg and tell your partner, whether it be your dog that's sitting close by, your stuffed animal, or a parent or sibling, how you could compare the layers of a hard-boiled egg and which layer would be considered the crust on the hard-boiled egg. Then we're going to talk about the mantle. You have a lower mantle, a middle mantle, which is where the convection currents are located, and an upper mantle. It is solid but capable of flow like hot asphalt or fudge. It's a thick substance. I kind of compare it to pancake syrup or molasses, and I call it sometimes a soliquid. It's like a solid but flows like a liquid. It's the thickest layer of the Earth, making up 70% of the Earth's mass. The hot material magma in the mantle rises to the top of the mantle, cools, then sinks, reheats, and rises again. These convection currents cause changes in the Earth's surface. If you remember the lava lamp we talked about, the inside of the lava lamp, how it would make the glitter rotate, that is like convection currents in the mantle. Then you have the outer core and the inner core. The outer core is a molten liquid metal that is about 4,700 degrees Celsius or 8,500 degrees Fahrenheit. It's located about 1,800 miles beneath the crust and is about 1,400 miles thick. It is composed of melted metals, nickel, and iron. Inner core. solid sphere composed mostly of iron. It is believable to be as hot as 6,650 degrees Celsius, 12,000 degrees Fahrenheit. Heat in the core is probably generated by the radioactive decay of uranium and other elements. It is solid because of the pressure from the outer core, mantle, and crust compressing it. The Earth is like a peach or a boiled egg. Turn to a seat partner and discuss these analogies. Okay, now if you compared with your seat partner, whether it be a sibling, a parent, stuffed animal, or your pet, now compare it to a peach. What part of the peach would be like the very inner core? Come up with another analogy and be prepared to share. Alright, so we're going to break down the mantle and the crust into those two layers that we talked about, and that's on the page that you have that was sent home, the lithosphere and the asthenosphere. The lithosphere is the crust and upper layer. It's the lower part of the crust and the upper layer part of the mantle. The asthenosphere is the layer of the mantle that consists of hot rock or tar-like consistency which slowly moves. That's where your convection currents take place. Here's a diagram of the asthenosphere. It is a soft layer of the mantle on which pieces of the lithosphere move. It is made up of solid rock like putty. It flows very slowly at about the same rate your fingernail grows. So it's a very slow process. The lithosphere, crust and upper mantle, is divided into separate plates, which move very slowly in response to the convecting part of the mantle. And that's what we're going to talk about starting tomorrow. Are you going to have some new stations over or plate tectonics? So be prepared for those. You'll have a read it and watch it tomorrow. And then Wednesday you'll have another challenge station and maybe a web quest. What do these two images tell us about the layers of the Earth? Look at there. What do we notice about the temperature? Think about the temperature when you are looking at this. What happens to the temperature as you enter from the crust and travel to the center of the Earth? Hopefully you have noticed the temperature changes, doesn't it? It increases as you go toward the center of the Earth. The temperature increases as depth increases. Depth meaning how deep you're going. Look at the information in the graph and table below. What's the relationship between depth and density / pressure? Right. As you get deeper, density and pressure also increase. Good job, guys. I know you were thinking like that. Density and pressure increase as depth increases. Temperature, density, and pressure increases as depth increases. Which layer of the Earth has the greatest temperature, pressure, and density? The core. And of course, it is in the center of the Earth. The Earth is layered with a lithosphere, crust and uppermost mantle, convecting mantle, and a dense metallic core. Pressure, temperature, and density increases as depth increases. I have loaded a rap about the layers of the Earth. It's kind of cute. So listen to that if you get a chance. It'll help you maybe get in your brain and you'll start remembering about the crust and mantle and bob your head. And this is the sheet that you will be working on. It is loaded in Google Classroom. It should make a copy for each of you so that you are not working on each other's copies. You do not have the diagram on the sheet. You just have questions 1 through 6 to answer, and make sure you turn those in for me to check. So be sure to submit them and then mark on your Google Classroom turned in. I will also be hosting a Google Meet today at 10 for any questions that you may have over anything that we have done, and just to say hi to you. I miss you guys so much. I miss doing fun things with you. I am going to have an activity that you can try at home with a plate tectonics this week, but don't go out and buy anything. I'll talk to you about some other things that you could possibly use, and I will be doing a Google Meet and showing you what that activity looks like. So you don't actually have to go out and purchase anything, but if you would, I'll send that information so you can be ready to do the activity with me on Google Meet. please stay germ-free and stay inside as much as you possibly can. Do go get you some fresh air, and don't spend all day on your Chromebooks. Do something fun. Play a game with someone in your family. Spend some family time. Okay? Don't stay in front of the TV, and don't stay in front of your Chromebook. This is Miss Warren. She misses and loves you all very much. Have a blessed day.